Dear students, today we shall solve some numerical problems in topic capacitors. The first one, a parallel plate air capacitor has got two square plates, each of side 0.5 meter and separated by 0.5 mm. Find its capacitance. If it is charged to a potential of 6 volt, find charge on the capacitor and energy stored in the capacitor. So here it is given that a parallel plate air capacitor has two square plates each of side 0.5 meter and separated by 0.5 mm. So this is the given statement. First you are asked to calculate the capacitance. C. So this is a direct substitution problem. The capacitance of a parallel plate capacitor, air capacitor, is given by epsilon naught A divided by D. You know the value of epsilon naught, and this A area, if A is the small a is the side of a square, then the area is given by A square. So D. So this A stands for side of the square. So this is 8.854 into 10 to the power of minus 12, and this A 0.5 square divided by D, separation between the plates, 0.5 mm. So now you calculate this capacitance. So here 1.5 cancels, this 0.5 means half, so it becomes 4.427 picofarad. So this is the capacitance. So if I round it off to 2 digits, it can be nearly 4.43 picofarad. In the second part of the problem, it is given that if it is charged to a potential of 6 volts, you are asked to find charge on the capacitor, energy stored. First you are asked to find charge on the capacitor. You know that Q is equal to C into V. That is 4.43 into 6 into 10 to the power of minus 12. So you do this calculation. Obviously you will get 26.6, nearly 26.6 nanocoulomb. Next you are asked to calculate energy stored, U. It is half CV square, half into 4.43 into 10 to the power of minus 12 into 6 square. So if you do this calculation, you will get nearly 79.7 nanojoule, because it is energy. You check those values. So side of a square plate is given, separation is given, you are asked to calculate capacitance. This is the formula. A stands for area of each plate. For a square plate, if A is the side, area becomes A square, so you will get capacitance. Afterwards, it is given that when it is charged to 6 volt, you are asked to find the charge. So this charge is C into V, you will get this much, and energy stored, this one. So these type of simple substitution problems will be asked in the board examination. If you know this formula, then from the data you substitute values in the formula and you get the answer. You look at the next one. A parallel problem is like this. A parallel plate capacitor collects a charge of 3 microcoulomb when connected to 1.5 volt battery with air as a dielectric. On replacing the air with a dielectric material, the capacitor collects 9 microcoulomb of charge. Find the dielectric constant of the material and also energy stored in it with the material as a dielectric. So here there is a parallel plate capacitor. When air as a dielectric, for a parallel plate capacitor, when air is dielectric, this charge is given as 3 microcoulomb and it is connected to a battery of 1.5 volt. So applied potential difference is 1.5 volt. Next, with a dielectric medium, with a dielectric medium other than air, the capacitor collects a charge of 9 microcoulomb at the same potential. So you are asked to calculate the dielectric constant of material. You are asked to find K. So for a parallel plate capacitor, when air is dielectric, it collects this much of charge at that potential. When a dielectric medium other than air is used, it collects this much of charge. So you are asked to find the dielectric constant. Since the capacitance of a capacitor, it is given by Q divided by V. So capacitance of this air capacitor, it is 3 microcoulomb divided by 1.5 volt. So it becomes 2 microfarad. Similarly, capacitance of the capacitor with dielectric, it is Q dash divided by V, that is 9 microcoulomb divided by 1.5 volt. So it is 6 microfarad. By definition, you know that capacitance of the capacitor with the dielectric, it is K times the capacitance of the air capacitor. Because you know this definition, dielectric constant is equal to capacitance of the capacitor with dielectric to ratio of capacitance of capacitor with dielectric to capacitance of the same capacitor with the air as a dielectric. Because of this relation, you get this one. So 6 microfarad, it is equal to K into 2 microfarad. Therefore, dielectric constant K is equal to 6 divided by 2, which is equal to 3. This is the first part of the problem. You are asked to calculate the dielectric constant, it comes to be 3. In the second part of the problem, energy stored in it with material as a dielectric. Energy stored in capacitor with dielectric medium. Energy stored in capacitor with dielectric medium. So U is equal to half CdV square. So half into this CD is 6, V is 1.5. So you do this calculation, it comes to be nearly 6.75 in 10 to the power of minus 6 joule. So 6.75 microjoule. So problems are based on the concepts. So you learn these concepts, this one and also this equation. By using them you can get the solution to this problem. You look at another one. There are two conductors. One of them has a capacity of 2 units and the capacity of other is unknown. They are charged until their potentials are 4 and 5 units. The two conductors are now connected by a wire. When their common potential is found to be 4.6 units, find the value of unknown capacity. Here there are two conductors. Another one, A, B. One of them has a capacity of 2 units. The capacitance of this A, it is a 2 unit. Capacitance of B, it is not known. They are charged until their potentials are 4 and 5 units. So this is charged till its potential is 4 units, and this is also charged till its potential is 5 units. The two conductors are now connected by a wire. The common potential is found to be 6 units. See, when they are connected like this, charge flows from one to another till the potential of both becomes same. So, on connecting them by a wire, given common potential difference V, it is equal to 4.6 units. From this you are asked to calculate this is CB. You are asked to calculate the CB. See, in the theory I told you that when two charged capacitors are connected in parallel, I have given the formula for common potential difference. So instead of capacitors, here conductors are used. So common potential difference V is equal to total charge divided by total capacitance. That is CA VA plus CB VB divided by CA plus CB. This is the formula. So this is the charge on the first one plus this is the charge on second one So this is the total charge and this is the total capacitance. You substitute all these values here. 4.6 is equal to CA 2 units, VA 4 units, CB not known, this VB 5 units, and this is 2 plus CB. Now you cross multiply, you take this CB common. So this is 9.2 plus 4.6 CB, it is equal to 8 plus 5 CB. So 9.2 minus 8, 9.2 minus 8, it is equal to 5 minus 4.6 into CB. So if I subtract, this is 1.2 and this is 0.4 CB. Therefore, this CB is equal to 1.2 divided by 0.4, which is equal to 3 units. So if you know this expression for common potential difference, then ultimately you can get the answer like this. Look at the next problem. In the next problem, it is given that the equivalent capacitance of 3 capacitors of capacitances C1, C2 and C3 connected in parallel is 12 units and the product C1, C2, C3 is 48. When C1 and C2 are in parallel, equivalent capacitance is 6 units. Find C1, C2 and C3. So here it is like this. Equivalent capacitance of C1, C2 and C3 in parallel is 12 units and C1, C2, C3 it is 48 units. Equivalent capacitance of C1 and C2 in parallel is 6. Equivalent capacitance is 6. So this is the given data. You are asked to find C1, C2, C3. So 3 statements are given, 1, 2, 3. 3 unknown factors are there. You write 3 equations for these 3 statements and you solve them, you will get C1, C2 and C3. So first it is given that when these 3 are in parallel, the equivalent capacitance is 12 and this is given as 48. And when these 2 are in parallel, equivalent capacitance is 6. So from these 3 statements, you are asked to find C1, C2 and C3. So as C1, C2 and C3 are in parallel, the first equation will be C1 plus C2 plus C3 will be equal to 12. Next, here when C1 and C2 are in parallel, effective capacitance is C1 plus C2, this is equal to 6. So from 1 and 2, from 1 and 2, 6 plus C3 is 12. This C3 is equal to 12 minus 6, it is equal to 6. You got C3. So this is equation 3. Since C1, C2, C3, it is 48. As you know, this C3, C1 plus C2 is equal to 48 divided by C3, 48 by 6, which is equal to 8. This is equation 4. From 2 and 4, you know C1 plus C2, you know C1, C2. You solve these two, you find C1 and C2. You already know C3. This one. From equation 2 and 4, from this equation 2 and equation 4, from these two equations, see, if I substitute C2 is equal to 6 minus C1 here, if I substitute C2 is equal to 6 minus C1 here, this will become a quadratic equation in C1. So by finding the roots of this quadratic equation, you can find C1. Then you will get C2. You can do it like that. In case, if you are unable to solve a quadratic equation, then by using this A minus B whole square formula, you can get A minus B. So here this A plus B is known. By solving those two, you can get C1 and C2. Since C1 minus C2 whole square can be written as C1 plus C2 whole square minus C1 C2. Instead of making it a quadratic equation, just you take the formula for C1 minus C2 whole square. See, the C1 plus C2 whole square is 6 square. 4 into C1 C2 is 8. So 36 minus 32, which is equal to 4. Therefore C1 minus C2 is equal to 2. This is equation 5. Now you solve 2 and 5. On solving equation 2 and 5, C1 plus C2 is equal to 6. C1 minus C2 is equal to 2. So if you add these two equations, 2C1 is equal to 8. Therefore C1 is equal to 4. C1 is equal to 4. Therefore C2 is equal to 2. Therefore 3 capacitors are of 2, 4 and 6 units. So this is the given problem and this is the corresponding solution. Now we shall go for the next problem. Two capacitors of capacitance 3 microfarad and 6 microfarad are charged to a potential of 12 volt each. So here there are two capacitors. C1 is 3 microfarad, C2 is 6 microfarad. They are charged to potential of 12 volt each. So this V1 is 12, V2 is also 12. They are now connected to each other with the positive plate of each is joined to the negative plate of other. What is the potential across each? So, if a positive plate of one is connected to negative plate of the other what is potential of each. So this is the problem. This is one capacitor, C1 3 microfarad, V1 12 volt. Say this plate is having a charge plus Q1 and this will be having charge minus Q1. Here there is another capacitor, C2, it is of 6 microfarad and charged to same 12 volt potential difference. So positive of one is connected to the negative of other like this. You are asked to find the potential of each. That means you are asked to find common potential difference. You know this formula, common potential difference. When oppositely charged plates are connected together, that is Q1 minus Q2 divided by C1 plus C2, that is C1 V1 minus C2 V2 divided by C1 plus C2. This is 3 into 12 minus 6 into 12 divided by 3 plus 6. So you find this value. You find this value, you will get nearly minus 4 volt. This minus sign is on account of the charge on the second capacitor, it is larger compared to the charge on the first one. So this is the common potential difference. Next one, capacitances of 3 capacitors on the ratio 1:2:3. Combined capacitance when joined in parallel is greater than that when joined in series by 180 by 11 microfarad. Find the individual capacitances. So the problem is like this. Capacitances of 3 capacitors on the ratio 1:2:3. C1 is to, C2 is to, C3 is equal to 1:2:3. So this is given. Their combined capacitance when joined in parallel, it is greater than that when joined in series is by 180 by 11 microfarad. So CP, it is greater than CS. Combined capacitance when connected in parallel, it is greater than combined capacitance when connected in series by 180 by 11 microfarad. So you are asked to find this C1, C2, C3. So this is the problem. The 3 capacitors have capacitance in the ratio 1:2:3. Their CP is greater than CS by 180 by 11. So you are asked to find what is the capacitance of these 3 capacitors. Here, if C1 is equal to C, if I take C1 as C, then C2 becomes 2C and C3 will become 3C, because they are in the ratio 1:2:3. When they are in parallel, when they are in parallel, this CP, C1 plus C2 plus C3, it is equal to C plus 2C plus 3C, it will be equal to 6C. This is equation 1. Next, when they are in series, 1 by CS is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So this is 1 by C plus 1 by 2C plus 1 by 6C. So if I take this 1 by C common, it is 1 plus 1 by 2, sorry 3 this is. If I take 1 by C common, 1 plus 1 by 2 plus 1 by 3. So it is 6 is the LCM. So 6 plus 3 plus 2. So this is equal to 11 by 6. Therefore CS, it is equal to 6 divided by 11. This is equation 6C divided by 11. This is equation 2. So it is 11 divided by 6C. So 6C divided by 11, that is CS. Since CP minus CS is equal to 180 by 11, this 6C, that one, minus 11 by 6C, it is equal to 180 by 11. So CP is greater than CS by 180 by 11. That means CP minus CS is 180 by 11. Now this CP, it is 6C. CS, 1 by CS is 1 by C into this term. So it is 6C by 11. Now you solve this one and you find C. ಇದನ್ನು simplify ಮಾಡಿ solve ಮಾಡಿದ್ರೆ C ಬರುತ್ತೆ. Once you get the value of C, you can get C1, C2 and C3. So you solve this part of the problem. CS is 6C by 11. So this is 66C minus 6C divided by 11. It is 180 by 11. So this term will cancel. 66C minus 6C is 60C is equal to 180. C is equal to 3 microfarad. Because this is given in microfarad. This being given in microfarad, C is equal to 3 microfarad. Therefore C1 is equal to 3 microfarad, C2 is equal to 6 microfarad, C3 is equal to 9 microfarad. You look at the next one. Two capacitors, 2 microfarad and 4 microfarad. Are connected in series to a 6-volt battery. What is the potential difference across each capacitor? So this is C1, this is C2. You are asked to find V1 and V2 and also energy stored in the combination. So this is the problem. So this problem can be solved in number of methods. The easiest way is by using the principles of series connection. You know that in series charge is same, applied potential difference is distributed in the inverse ratio of their capacitance. So in series Q on both is the same, therefore this V is inversely proportional to C. Therefore C1 V1 is equal to C2 V2. Therefore this V1 by V2, it is equal to C2 divided by C1. So V1 by V2 is equal, this C2 by C1 means 4 by 2. So it is 2 divided by 1. This is equation 1. But the same applied potential being distributed, V1 plus V2 is equal to 6. So here V1 plus V2 is equal to 6 means if I divide both sides by V2, V1 by V2 plus 1 is equal to 6 divided by V2. What is this V1 by V2? In this equation it is 2. So 2 plus 1 is equal to 6 by V2. So V2 is equal to 6 by 3, that is 2 volt. Therefore this V1 is equal to 4 volt. This is the easiest way of solving this problem. In series connection, charge on both is same. Therefore the potential difference across each capacitor is inversely proportional to capacitance. Hence C1 V1 becomes equal to C2 V2. So this is V1 by V2, but sum of the potentials is equal to applied potential 6. Therefore on simplification you will get V1 and V2. This is one way of doing this problem. The other way is you find CS. CS is equal to C1 C2 divided by C1 plus C2. Because 1 by CS is 1 by C1 plus 1 by C2. If you take LCM and if you write for CS, it becomes C1 C2 divided by C1 plus C2. So it is 2 into 4 divided by 2 plus 4. So it is 8 by 6, which is 4 divided by 3 microfarad. Therefore charge on each capacitor Q is equal to CS into V, that is 4 by 3 into 6. So it is 8 microcoulomb. 4 by 3 into 6, it is 8 microcoulomb. Therefore this V1 is equal to Q divided by C1. So 8 microcoulomb divided by C1 is 2. So it is this V1 is Q divided by C1. So 8 by 2, which is 4 microfarad, and V2 Q by C2, that is 2 microfarad. sorry, 2 volt. So V1 is 4, V2 is 2. You got the same thing. So this is another way of solving this problem. So when these type of questions are asked, you can do whichever method you like. So in the second part of the problem, you are asked to calculate energy stored, U. Energy stored in the combination. So it is half CSV square. That is half, what is the CS? 4 by 3 in 10 to the power of minus 6 and 6 square. So you do this calculation, it comes to be nearly 24 in 10 to the power of minus 6 joule. So roughly you will get this much. You look at the next one. Equivalent capacitance of two capacitors when series 1.875 microfarad, when parallel 8 microfarad. Find the individual capacitances. This is the problem. So for two capacitors, equivalent capacitance in series 1.875 microfarad, equivalent capacitance in parallel 8 microfarad. You are asked to find capacitances of the two capacitors. So here there are two capacitors. When they are connected in series, this is the equivalent capacitance. When the same two are connected in parallel, this is the equivalent capacitance. So you are asked to find the individual capacitances. So first we assume that let C1 and C2 be individual capacitances. Therefore, 1 by Cs is equal to 1 by C1 plus 1 by C2. Therefore, Cs is equal to C1 C2 divided by C1 plus C2, which is equal to 1.875. Therefore, C1 C2 is equal to 1.875 into C1 plus C2. So this is equation 1. Similarly, Cp is equal to C1 plus C2, which is equal to 8 microfarad. This is equation 2. Therefore, C1 C2, it is equal to 1.875 into 8. You do this calculation. How much you get? So C1 C2 is equal to 15. This is equation 3. Now you know C1 plus C2 and you know C1 C2. As you did in the earlier problem, by taking C1 minus C2 whole square formula, you find C1 and C2. Instead of going for a quadratic equation, you take this formula. So this is 8 4 and this is 15. So 64 minus 60, which is equal to 4. Therefore C1 minus C2 is equal to 2 microfarad. You know C1 plus C2 and you know C1 minus C2. So this is equation 4. On solving 2 and 4, if you solve these two, 2C1 will become 10, C1 is equal to 5 microfarad, C2 will become 3 microfarad. So in the board examination, if you are asked to find C1, C2 by giving equivalent capacitance series in parallel, you have to write all these steps. Whereas in competitive examinations, if you are asked this type of problem, out of the 4 given answers, just you make an inspection. Instead of going through this procedure, just by inspection, by using these two formula, CS and CP, you can find C1 and C2 easily less than 1 minute. You look at this next one. A 4 microfarad capacitor is charged to 200 volt. It is then disconnected and connected to another uncharged 2 microfarad capacitor. How much energy of the first capacitor is lost in the form of heat and electromagnetic induction? So here there are 2 capacitors. A capacitor C1 of 4 microfarad, it is charged to 200 volt. After charging, it is disconnected from the battery and connected to another uncharged 2 microfarad capacitor. So here this is C2, this is of 2 microfarad, it is uncharged, that means it is 0. Now, when this is connected in parallel like this, when this uncharged capacitor is connected to this charged capacitor, how much energy is lost in the form of electromagnetic radiation? So here this can be done in 2 ways. The first way is you calculate the initial energy stored in both of them. After connecting them in parallel, they acquire common potential difference. You find out the energy after they acquire common potential difference and you subtract those two, you will get energy loss. Or otherwise, straight away you can take this formula. Half C1 C2 divided by C1 plus C2 V1 minus V2 whole square. You know C1 C2, you know V1 and V2, so you can calculate this one. You can do it like this also. So you try this problem on your own. In the next class, we shall take up some network problems.